Okay, so hello and welcome back. So continuing the same discussion with question number 2. Now we want to make sure that basically g of y is the inverse of f of x. Now in order to do that, we need to show that basically so since g is the inverse, is supposed to be the inverse of f, g of is supposed to be the identity function on the domain of f. This is the domain of f. X denotes the domain of f, and fog is supposed to be the identity function on the domain of on the codomain of f, right? So now let me make a screenshot here, and then we will move to another sheet. Okay. So we want to show that g of is equal to I of x, and fog is equal to I of y. Now, basically what we had here was that basically f of x was equal to basically this x minus 1 for odd x's, and x plus 1 for even x's. And we had basically g of y as basically y plus 1 for even y's, and y minus 1 for odd y's. Now g of here is the same thing as g of f of x. Now you can see that g has two clauses. It has one clause for even y's and one clause for basically for odd y's. Now the input of this function, the input of basically what you want to put into g here is f of x, right? So here if y is supposed to be equal to even, that means that and since you are inputting f of x into the function, that means that then the f of x has to be even here, right? So then if I'm using basically, for example, y plus 1 over here, then I have to make sure that basically what I choose from here is going to be an even number. Otherwise, I'm not supposed to enter it into the function that way. So over here we said that when we input some odd x into f of x, the output is going to be an even f of x. And we said that over here, when we input some even x into f of x, the output is going to be some odd f of x, right? So now what I'm going to do is that I'm going to use g of y, and I'm going to use this clause over here. So this clause needs an even y, and even y needs basically this even f of x, which is x minus 1, right? So now I put this x minus 1 instead of y here, so x minus 1, and then I have a plus 1 here, and then I will get an x. On the other hand, there is another possibility for me, meaning that I can write g of and that is again equal to, of course, g of f of x, and I can use this part of g of y, this part of g of y, which is y minus 1. But this time I need an odd y. I need an odd y, which means that an odd f of x here. So I'm going to use this clause and put it into here. So that gives me x plus 1 minus 1, which is equal to x. So in both of these cases, g of is equal to x, which means that basically g of is the identity function on the domain of f. Okay. Now, the second part of this is that we need to show that FOG is equal to I of y. Now, FOG is the same thing as f of g of x. Is the same thing as f of g of x. Now, so what I want to do is that I want to use this function as the function g of x as an argument for the function f of x. So here basically I have odd inputs, here I have even inputs, and here basically in this function, basically you know that when you input an even y into this function, even plus an even number plus 1, it is going to give you an odd number, which means that these are all odd g of y's, and this would be all the even g of y's, right? So what that means is that now I'm going to use f of x. So for example, this part, and basically the input is supposed to be an odd input. So I'm going to use this odd input here and use y plus 1 as an argument to this function. So that would be y plus 1 minus 1, meaning that wherever you see x in f of x, you have to substitute it with the function g of y. And the function g of y, I'm supposed to use this clause of g of y because this gives me an odd output or odd g of y basically. So what that means is that basically then I put y plus 1 instead of x. So this is going to y plus 1, and then I have a negative 1 over here, and that gives me a y. Now, I can use the second clause of f of x as well. I can write FOG is equal to f of g of x, and then basically f of g of x. So now I'm going to use this part, right? The second clause. Here, basically the input to this function is supposed to be an even number. An even number would be an even g of y, which is, this is actually supposed to be g of y. And this is also supposed to be g of y, right? So I start over. So I'm inputting g of y into f of x. So we were supposed to use the second clause of f of x. So here we need an even x, or an even input. So an even input would be an even g of y. So an even g of y would be y minus 1. So instead of x, I write y minus 1. And then I have a plus 1 over here. So that gives me a y. So in both of these cases, as you can see, FOG is equal to y, which means that FOG is equal to I of y. And therefore, you have, this way you have made sure that you have made sure that g of y is actually the inverse of f of x. So you can write, therefore, g as a function from w to w defined as g of y is equal to y plus 1 for even y's and y minus 1 for odd y's, is the required inverse for the function f, which was a function from w to w as well, defined as f of x. F of x is equal to x minus 1, x plus 1, and this was for odd x's, and this was for even x's. That is basically the conclusion, and that is the inverse of this function. Okay, so that was question number 2. Now let's see what we have with question number 3. Okay, so the next question that we have is question number 3, which is basically if f is a function from R to R, is defined by f of x is equal to x squared minus 3x plus 2 minus 3x plus 2. Find f of x. Okay, so when you want to find f of x, basically the argument of the function f, which is basically all of the variables that you can see, wherever you see a variable in the function f of x, that becomes basically that is where the argument goes in. So when you enter some x into this function, then that x goes here in, and that x goes here in, and so on and so forth. So then all of these arguments have to be replaced by this argument, which is, well, f of x, and f of x is basically this whole function. That means that this function f of x becomes x squared, and so then instead of x you have to write the whole function f of x, which means that x squared minus 3x plus 2 whole squared, and then you need to write minus 3 times, again, x is the whole function f of x, so x squared minus 3x plus 2 and plus 2. So here, as you can see, there is no argument, there is no variable, so you can just leave it like that. Now this function here is the same thing as this is the same thing as, well, in order to raise this to the second power, you have 3 basically it's not easy to raise this to the second power. So what I'm going to do is that I'm going to write this as, so when you want to, so you can write this as x squared minus 3x plus 2 whole squared. You want to calculate this, and of course you can you can regard this as, for example, a plus b plus c, for example, whole squared, and there must be some formula for that. Probably that would be basically a plus b plus c times a plus b plus c, which is equal to, for example, a squared plus ab plus ac plus ab plus b squared plus bc, for example, plus ac plus bc plus c squared. So you can see that you have a squared, b squared, c squared, a squared, b squared, and c squared, a squared, b squared, c squared, and then you have ab, so you have ab and ab plus 2 times ab, plus, well, 2 times ac, probably 2 times ac, and then you have 2 times bc, which you can write as, for example, a squared plus b squared plus c squared plus 2 times ab plus ac plus bc. That you can write as a plus b plus c whole squared, right? Oh, but when you don't really need to know this formula, what you can do is that, well, I wish I haven't, let's do it in a different way. So what you can do with this, basically you can, excuse me, so you can write this as, simply as for example, x squared minus 3x minus 2, right? So you have to change this sign as well, because that's negative 3x, negative into negative is positive, and then raise this to the second power, and then this becomes now the same thing as a squared minus b squared, a minus b whole squared. This becomes the same thing as a minus b whole squared, which is equal to a squared minus 2ab plus b squared, right? And then again you can do the same thing, but let's see what happens if you do that. So then if I write this as a squared, that would be, for example, x squared raised to the second power would be x raised to the power 4, and negative 2 times a times b, so negative 2 times a, which is x squared, times b, which is 3x minus 2, plus b squared, which is 3x minus 2 whole squared. And again you will have to apply the same formula here one more time, which is the same thing as x raised to the power 4 minus 2 times x, so 2 times x squared times 3x would be 6 times x raised to the power, this would be 2 times 3 is equal to 6, and x raised to the power 3. And then you have negative 2 times negative positive 2 times 2 is equal to 4, x raised to the power 2. And then over here you have 3x minus 2 whole squared is again a squared minus 2ab plus b squared. So you have plus a squared, which is 9x squared, minus 2ab, so negative 2 times 3x times 2, which is the same thing as 4 times is equal to negative 12x. And then you have basically a b squared there, so that's equal to 4, and that gives you x raised to the power 4 minus 6 times x cubed, 4 plus 9 is equal to 13 times x squared minus 12x plus 4, minus 12x plus 4, 12x plus 4, right? So that is And then you need to put this whole thing over here. So this becomes basically this part here. So this is this part. I can write it as x raised to the power 4 minus 6x cubed plus 13x squared minus 12 times x plus 4. And then you can multiply this negative 3 by all of these terms, which is negative 3x squared plus 9 times x. Negative 3 times negative 3 is equal to plus 9 times x, and negative 6 plus 2 and so if you add all of this together, what you will get is, well, x raised to the power 4, and we have negative 6 times x cubed. Now negative 13 minus 3 is equal to plus 10 times x squared. You have x over here and x over here. Negative 12 plus 9 is equal to negative 3 times x. And 4 minus 6 is equal to negative 2 plus 2 is equal to 0. So the whole thing becomes x raised to the power 4 negative 6 times x cubed plus 10 times x squared minus 3 times x. And that is the correct answer.